Hey listeners, I'm back with a new season and new episode of What the Perf podcast after a long time. It's been quite some time since we did an episode. Both I and Nitesh have been very busy lately, but we decided to make a few changes to the format of this podcast. I now have a new co host, Karan. I and Karan have worked together at my current organization for about a year. Karan, would you like to give a quick intro of yourself?
Sure, Mrinal. Hello, listeners. I'm Karan. I have around 5 years of experience as a software engineer with focus on performance, scalability, and reliability. For the initial part of my career, I was a part of performance engineering team with a telecom giant, and now I'm working with an e-commerce startup.
Thanks, Karan. Welcome to What the Perf podcast.
Thanks, Mrinal.
The other changes are that there'll be no news section. There are already so many news sources to get your performance news from on LinkedIn. I personally follow Naveen Kumar to get my dose of performance news. So you could also do that. The last change is that we will not have the what the crash section. It'll be occasional. If we find something worthy of covering, we will include it in an episode. Going forward, I and Karan are going to cover some computing concepts in the upcoming episodes, which will help listeners build on their fundamentals. We will keep it short, a maximum of 15 minutes. We will also do interviews with performance professionals occasionally. We'll do book reviews and explainers as was originally planned. Also, a highlight the what the perf podcast has been in existence for more than 2 years now. We really hope we have been able to have a positive impact on performance engineers. So, this week's topic is caching. So, let's get started. What's the need for caching? Imagine you are a research student in the 80s or 90s. Your main source of research were books. You depend on books for your research, and you have to visit the library every day to select books to read for your research. Now, to have continuous access to all the books, you need to be in the library all the time. You can't have the comfort of your home while you're reading, and the library also has limited working hours. So, you decide to take home a select few books which have sufficient material to cover for the next few days of your research. By taking home few books to read, you did two things. One is you reduced your daily commute to the library, which would take considerable amount of your time. You get access to the few important books that are important for your research and which you will frequently refer to throughout your research. This, in essence, is caching. Computer science is full of trade offs. One of the most important ones is the trade off between fast access versus large storage spaces. If you want fast access, you have to compromise on storage space. If you want more storage space, you have to compromise on fast access. This is why or how caching came into existence. When it was not possible to have unlimited storage with fast access, computer scientists came up with different levels of storage with varying levels of access speeds and storage capacities. So, what is caching? In a sentence, caching is a small memory with fast access and local storage where we store frequently accessed data. Karan, would you like to continue further on some other caching concepts?
Sure, Mrinal. To understand caching further, we need to understand cache reads and writes. There are a couple of data access strategies used while designing an application. The strategies defined dictates the relationship between the data source and the caching system. So it's very important to choose a proper data strategy. Now, there are different patterns in which caching is implemented. It might be proactive or a reactive approach. In other words, it's all about how the data is written or read. The first strategy would be cache aside or lazy loading strategy. When your application needs to read from a database, it checks the cache first to determine whether the data is available. If it is available, The cache data is returned and response is issued to the caller. If data is not available, the database is queried for data and then the cache is populated. The second would be write through strategy. In this write strategy, data is first returned to cache and then to the database. The cache sits in line with the database and writes always go through cache to main database. This would mainly improve the consistency between the caching system and the database. The third one would be write behind caching. This strategy allows the application to write data directly to the caching system. This data is then synced asynchronously to the underlying data source. The caching service needs to maintain a queue of write operations so they can be synced in order of insertion. All these strategies have some pros and cons, and it majorly depends on the use case which we are solving. Now that we have an idea of data access patterns in caching, we need to solve the next challenge, which is how to make room of new data. This is achieved by cache algorithm policies. The first one would be first in, first out strategy. This cache evicts the first block accessed first without any regard to how often or how many times it was accessed before. Last in, first out. The cache evicts the block accessed most recently first without any regard to how often or how many times it was accessed before. The third one would be least recently used. It discards, as the name suggests, it discards the least recently used items first, then most recently used. It discards, in contrast to LRU, the most recently used items first. The next one would be least frequently used. It counts how often an item is needed. Those that are used least often are discarded first. And the final one would be random replacement. It randomly selects a candidate item and discards it to make space when necessary. Now, as discussed earlier, cache helps to improve performance at various levels in an application. Now, what are the major indicators or metrics that we need to look into to make use of cache most efficiently? Memory consumption of cache, CPU, and throughput at which it serves the request are the most important metrics while considering cache performance. However, the most important way to measure the performance of a cache is in terms of a quantity called hit ratio. The cache hit is when you look something up in cache, it was storing the item, and it was able to satisfy the query. A cache miss generally is when something is looked up in the cache and is not found. The cache did not contain the item being looked up. This would then result in querying the L2 cache or the data store to fetch the required data. Mrunal, would you like to tell listeners more about caching and at what levels can it be used in an application?
Sure, Karan. So now that we have heard some basics about caching, we should visualize all the places where caching has been implemented in order to appreciate the role it is playing in improving performance of modern applications. Starting from the lowest level to the highest level, you have caching in these following areas. There is L1, L2, and L3 cache at the CPU chip. There are caches at disk, RAM, and OS level. You have caches maintained at application runtimes like your JVM, CLR, etc. Your browsers have caching. They cache uh, resources such as image files, CSS, etc. locally. There are distributed systems that may have their specialized caching layers. For example, Redis, Memcached. These are there to facilitate fast access to frequently used data. And finally, a form of distributed caching where static content is cached at multiple geographic locations, which are called as CDNs. So caching at multiple layers over the years has helped speed up our web applications and resulted in better performance for the end user. Thus, understanding caching and its complexities is a great tool to have in a performance engineer's toolkit. With that, we would like to wrap up this episode. I hope we have generated enough interest in our listeners to understand caching further. See you in the next one.
Thanks for joining in. Bye, listeners.